We are going to discuss about dispersion. What is meant by dispersion? Splitting of white light into 7 component colors. That phenomena in light is called dispersion. Whenever light is passing through a prism, it splits into 7 colors. The arrangement of these colors on the screen is called spectrum. That is called a spectrum. So a light ray which has more refractive index bends more. A light ray which has a less refractive index bends less. Dispersion through the prism. So now we are going to derive refractive index of prism. So ABC is a prism. It has 2 refracting surfaces, AB and AC. This is nothing but what? Angle of prism. The angle between 2 refracting surfaces is called angle of a prism. So whenever a light ray strikes the first refracting surface at an angle I, the light ray undergo refraction and it travels into the prism and it strikes second refracting surface at an angle R2 and emerges out with an angle E. So this is the angle of refraction at the first refracting surface, and this is angle of deviation. Angle of deviation. What is meant by angle of deviation? Angle of deviation is nothing but it is the angle between emergent light ray and incident light ray. That is angle of deviation. That is nothing but what? Angle of deviation. Now we are going to derive refractive index of prism by doing a derivation. So here AQNR is a quadrilateral. AQNR is a quadrilateral. So in quadrilateral we know that sum of the angles becomes 360. So that here angle A plus this angle is 90 plus this QNR, angle QNR plus this angle also 90 is equal to 360 degrees. So here angle A plus angle QNR is equal to 90 plus 90, 180. So 360 minus 180, that is equal to 180 degrees. Now we take another triangle here, QNR. In triangle QNR, sum of the angles in a triangle is 180 degrees. So here R1 plus angle QNR plus R2 is equal to how much? 180 degrees. So here R1 plus R2, R1 plus R2. So here angle QNR is equal to, from 1, what we write here? 180 minus A plus 180 minus A is equal to 180 degrees. So R1 plus R2 is equal to A. This is equation 2. This is equation 2. So now this is angle of deviation. Angle of deviation. We know that in mathematics the external angle is equal to sum of the internal angles. So this is I, this total angle is I, and this is R1. So what is this angle here? I minus R1. So this is E and this is E. This opposite angle, this is E, and this angle is R2. So what is this angle here? This angle is nothing but, this is I minus R1. So here this angle is nothing but E minus R2. So here total deviation total deviation delta is equal to what we write here, I minus R1 plus E minus R2. So that is equal to here, what we write here, I plus E minus of R1 plus R2. This is equation 3. Equation 3. Now let us draw a graph between angle of incidence and angle of deviation. We get this type of graph, parabola graph. So here observe, as the angle of incidence increases, angle of deviation decreases and it reaches to minimum value. And once it reaches to minimum value, if the angle of incidence is increases, then what happens here? Angle of deviation also once again increases. So here we take one angle. So this is the delta 1, that is the one deviation angle. The corresponding angle of incidence is here I. Now we take another angle, angle of deviation 2. The corresponding angle of incidence is I. So here we draw the line from this point, from this angle. So it cuts parabola at 2 positions, at 2 points. Now the corresponding angle of incidence for angle of deviation d2 is I. From this side E. So that means what? Angle of deviation, when angle of deviation decreases, these I and E comes closer. At a particular angle, then what happens? When deviation reaches to minimum value, then this I, this E, both are equal. Angle of incidence and angle of emergent ray, both are equal. So at minimum deviation, at delta is equal to delta m, dm. So what happens here? I is equal to E. When I is equal to E, then automatically R1 is equal to R2, that is equal to R. So substitute this value in this equation, delta is equal to, here I is equal to E. So put I for E. So I plus I, that is equal to I minus of R1 plus R2 is equal to how much here? R1 plus R2 is equal to A. Okay. So delta is equal to here dm. So dm is equal to 2I minus A. So take this A to this side. A plus dm is equal to I. So I is equal to, we write here, A plus dm by 2. Already here R1 is equal to R2 is equal to R. Substitute this value in this equation. We get R plus R is equal to A. That is equal to 2R is equal to A. R is equal to, we write here, A by 2. We know that formula, refractive index of prism, N is equal to sin I by sin R. Sin I by sin R. So N is equal to sin, what is the value of I here? A plus dm by 2. What is the value of R here? Sin A by 2. Sin A by 2. So this is the expression for refractive index of a prism. If A plus dm by 2, sin A plus dm by 2 is equal to A plus dm by 2, sin A by 2 is equal to A by 2. If these are the small angles, then what happens? Sin theta almost are equal to theta. So here N is equal to what we write here? A plus dm by 2 divided by A by 2. 2 cancel. So here N is equal to, we write here, A by A, 1 plus dm by A. 1 plus dm by A. So here N minus 1 is equal to dm by A. So A is equal to, we write here, dm by n minus 1. This is expression for angle of prism. And also we derive one important formula for small angle prism. For a small angle prism, here dm is equal, we write A into n minus 1. This is the expression for refractive index of a prism. So now we are going to discuss about applications of dispersion. Rainbow is best example for dispersion of light in atmosphere. So how the rainbow is formed? What are the conditions required to see the rainbow? Rainbow is combined effect of reflection, refraction and dispersion. To observe the rainbow, half of the sky is shining, half of the sky is raining, and your back is facing towards sun. Then only we can observe rainbow. So here let us discuss rainbow by taking two droplets in atmosphere. One droplet is higher in atmosphere than second droplet. So this is sunlight. Whenever this sunlight enters into the drop, one refraction takes place. This light ray is internally split into 7 colors. Let us take one color. This light ray is internally split into 7 colors inside the drop. These colors are incident on the other end of the drop greater than the critical angle. So whenever these light rays are greater than the incident greater than the critical angle, these colors again reflected and they emerges out. So here violet color goes along this direction and red color reaches to our eye. So here from one drop we can see only one color. Depending upon position of the drop, we can see only one color. So if the angle between incoming sunlight rays and emergent light rays becomes 42, we can see red color. So if the angle between incoming sunlight rays and emergent light rays becomes 40 degrees, then we can see violet color. In between these two angles, 42, we can see remaining all colors. So this is called primary rainbow. Primary rainbow is a 3-step process. Here one refraction, one reflection and another refraction takes place. So as a result, here we see red on the top and violet on the bottom of the rainbow. This rainbow is called primary rainbow. So let us consider second drop. Here also only one color reaches to observer eye, that is violet color, and remaining colors goes in different directions. So this is about primary rainbow. Sometimes another rainbow is formed, that is secondary rainbow. Two rainbows are formed. So here secondary rainbow is 4-step process. 4-step process. 2 refractions and 2 reflections takes place in the secondary rainbow. Here the incoming sunlight rays are enter into the drop and these are internally reflected and they strikes the other end of the drop with greater than the critical angle. Again they refracted. Okay, here 2 reflections are takes place and they emerges out as different colors. That means here 2 refractions and 2 reflections here takes place. So from this drop only one color reaches to observer eye, that color is violet color. From this drop only one color reaches to observer eye, that color is red color. That means what are the difference between primary rainbow and secondary rainbow? In secondary rainbow colors are inverted. On the top we see violet color, on the bottom we see red color. So secondary rainbow is fainter compared to primary rainbow. Why? Because here number of reflections and refractions are more, so that intensity of light is decreases, so that the secondary rainbow looks fainter compared to primary rainbow. So this is very, very important question for IP examination. So in this way rainbow is formed. So now let us discuss about compound microscope. So to get large magnification, we use another microscope, that is compound microscope. So this compound microscope has two lenses. One is objective lens and another is eyepiece. The lens which is close to objective, that is called objective lens, and the lens which is near to eye, that is called eyepiece. So the distance between objective lens and eyepiece is nothing but L. Now we are going to discuss how compound microscope working. Whenever an object of height h is placed in between f0 and 2f0, then by the property of convex lens, this objective lens forms image, that is real inverted image, beyond 2f0, that is the height of that image is nothing but h dash. So the image formed by one lens acts as object for another lens. So if this image is adjusted below the focus of eyepiece, then eyepiece forms virtual image at the least distance of distant vision, D. That means in the compound microscope, eyepiece acts as simple microscope. So here the distance between this image and optic center is V0, and the distance between this optic center and object is nothing but U0. Now we can find out magnification of compound microscope. So m is equal, what we write here, m0 into me. m0 means what? Magnification of objective lens. So m0 we write here, height of the image h dash divided by height of the object h. Here we follow some approximation. So that is equal to, here we write here V0 by U0. So if this image is adjusted very near to the eyepiece, then V0 almost are equal to what we write here, L. And also this image is adjusted very close to the objective lens, U0 almost are equal to F0. U0 almost are equal to F0. అంటే కొంచెం ముందు జరిపినప్పుడు ఆటోమేటిక్గా V0 is almost are equal to L. ఇది కూడా కొంచెం ముందు జరిపాను అనుకోండి, U0 almost are equal to F0. Substitute these values in this equation. M0 is equal to what we write here, L by F0. M0 is equal to L by F0. This is the magnification of objective lens. Now magnification of eyepiece, ME. Already this eyepiece forms image at D. This is happened in a simple microscope. So in compound microscope, eyepiece acts as a simple microscope. So ME is equal to, directly we write 1 plus D by FE. In simple microscope, what we write here, what we write there? When the simple microscope forms a virtual erect image at D, then magnification is nothing but ME is equal to what? 1 plus D by FE. So here magnification is equal to, combined magnification is equal to M0 into ME, that is equal to here L by F0 into 1 plus D by FE. So M is equal, we write here L by F0 into, when eyepiece forms image at infinity, then the magnification is becomes d by fe. Magnification decreases. Magnification decreases. So this is the magnification of compound microscope. Magnification of compound microscope. M is equal to LD by F naught into Fe. So now we are going to discuss a very important definition, that is power of a lens. What is meant by power of a lens? So power of a lens is nothing but the tangent angle by which a lens diverges or converges the light rays, or which are falling unit distance from the optic center. That tangent angle, what we call here power of a lens. So here tan delta is equal to, what we write here, tan delta is equal to h by f. H by f. So this tan delta is equal to power. Power. That means power is equal to, here h. The light rays are falling at a height 1 meter from the optic center, or unit distance. So put h is equal to 1. P is equal to 1 by f. So this is called power of a lens. Or you can say power of a lens is nothing but reciprocal of a focal length. If the focal length is more, then power of a lens is less. If the focal length is less, power of a lens is more. Power of a lens is positive for convex lens. It is positive. It is positive for convex lens. And it is negative for concave lens. For concave lens. This is about power of a lens, and units of a power of a lens is nothing but meter inverse or diopter This is about power of a lens. Very, very important definition. Let us consider two thin lenses. They are in contact each other. Now we are going to find out effective focal length of these thin lenses in contact. The focal length of first lens A is f1. The focal length of second lens is f2. Here O is the object which is kept beyond the focus of first lens A. So the light ray which is coming from object O incident on a first lens, and it forms image I1 at a distance V1 from the common center. This image acts as virtual object for the second lens, and second lens forms image I at a distance V from the common center. Now we are going to derive combined focal length of this system. So for lens A, what is the lens formula here? 1 by f is equal to 1 by v minus 1 by u. Okay. So 1 by f1 is equal to 1 by, image distance is nothing but v1 minus 1 by u. This is equation 1. And for lens B, so 1 by f2 is equal to 1 by image distance is nothing but v minus object distance is nothing but v1. So this is equation 2. Adding 1 and 2. What we get here? Add 1 and 2. So here 1 by f1 plus 1 by f2 is equal to, here v1, 1 by v1 minus 1 by v1 cancel. So that is equal to what we get here, 1 by v minus 1 by u. But what is 1 by v minus 1 by u? 1 by f. So 1 by f1 plus 1 by f2 is equal to 1 by f. So this is the expression for effective focal length of a combination of two thin lens contact. So we write here power 1 by f is nothing but power of the lens is equal to P1 plus P2. So the power of the combination is equal to sum of the powers of the individual lenses in contact. P is equal to P1 plus P2.